So I'm going to talk about black box mutation testing, some ongoing work. We have this little implementation of bucket sort, and we want to test it. So we have a trusted sorting function already. It's very easy to test this in a very efficient way, very effective way. But it's also pretty easy to test it in a similar but very bad way of this extra B, which is inserted. And what I'm thinking here is that mutation testing would be nice, because if I use this first test case here, it's, if I do some random change to how to desort, then this property will be falsified, whereas the other one will not. So expect some kind of, the bad thing here is that we get the same output from quick check in both cases, right? So the problem is, of course, that we're testing a function that actually works. So you shouldn't do that apparently, because then you just get this past 100 tests, and I would want some kind of warning light here that doesn't actually do anything. Right, so mutation testing can be used for that. So instead of traditionally you do these mutations by changing something syntactically in the definition of these desort functions. But since we have higher order functions, we don't have to resort to changing the syntax in order to change functions and manipulate functions like any other value, right? The first thing that we do is to just factor out the code that we are actually testing, desort in this case, and on all our properties. And then it's pretty straightforward, right? But we define a class of types that we can mutate. And for these algebraic types, it's pretty straightforward. We swap some constructor somewhere. Defining this kind of function reminds pretty much of defining a function, which is also something we use in fiction. And then we have an instance for functions. So, and I mutate functions by mutating the output. I don't have time to explain exactly how, but you can do it in slightly various different ways, and you get slightly different results. Okay, and then I have a little mutation testing framework. It's really tiny to how mutation testing framework really is, I guess. I've actually written it inside the property language of QuickCheck, so it doesn't have to modify QuickCheck in any way. It's just defined in the property language. These are testable on property of QuickCheck types. And what it does, it takes one of these properties, which is parameterized by something that we can mutate, function typically, and it takes the original function, and then it tests, it generates random test cases and tests the original function, but it also, for every test case, it generates a random mutant of the function and tests if that falsifies the property. And then it collects how many of these mutants falsify the property, and we get that mutation score up. So I'll show you how that works. So these are the two extreme cases, right, where in the first one all mutants are killed, because it's a very good specification, and then the second one is where I done this mistake of using desort in both places, and then all mutants survive.
So the goal is to try to tell you whether the test is any good.
Yes, the goal is to sort of take this problem that I have here, that the property says absolutely nothing about the function. If I change the function anyway, the property will still hold. But there are also cases in between this, right? So like here I say that I specify the sorting function by saying that the output is ordered and the length is unchanged, and then I get 85% mutation score. If I didn't have checking the length, I would get the lowest score, 50%. And yeah, so the definition sort of this mutation score is that it's the probability that a random mutant input pair falsifies the property. because what it's done is it has 100 mutants and it tests for the same test cases that it tested the original function. Right, that's it. So it's a nice little idea, and it's very easy to implement. It's almost as short as it's not to implement it. And, I mean, so the thing about this D-sort, we don't know how it's implemented, right? It could be just standard Haskell or maybe even FFI, and I mean, how would we mutate that syntactically? It's almost impossible in the general case. But here it just works because it uses a more semantic approach to mutating functions and syntax. Thank you.
As Richard began his talk,